An action potential is when there is a change in charge across a membrane down an axon, transmitting electrical impulse.
This is what a neuron looks like in resting potential. So there are a lot of sodium ions on the outside of the neuron, whereas there are a lot more potassium ions on the inside of the neuron. And there are also different there are lots of different channels, protein transport channels on the membrane, which is a lipid bilayer.
It requires ATP to move potassium and sodium against its concentration gradient. There is a net charge across the axon membrane. The inside of the axon is more negative than the outside because there are more positive ions on the outside of the membrane.
At resting potential, an axon is polarized and has a charge of negative 70 millivolts across the membrane. At the axon terminals, the electrical message is relayed through the synapse to the dendrites in another neuron, which triggers depolarization in the axon. If the depolarization meets a threshold, then the sodium channels open and the sodium travels inside, which makes it positive relative to the outside of the axon membrane. And this is called depolarization. At 40 millivolts, the sodium channels close and the potassium channels open, allowing potassium to leave the cell. This makes the inside more negative relative to the outside. Then the potassium ions go out of the cell in repolarization to make the inside more negative, like in the beginning, resetting the membrane potential. Sometimes too much potassium leaves the cell since there is a lag in the opening and closing of the protein channels. So, in order to reset the membrane potential, the sodium and potassium ions may diffuse in or out, whichever one is down their concentration gradients, to counteract the hyperpolarization which occurs when too much potassium goes outside of the membrane. This brings the membrane charge back up to negative 70 millivolts, and this period is called the refractory period.
Now the membrane potential is back to the resting potential and the message is relayed on to other axons. The end. Hope you got the message.